Hello guys, today we are studying a new point, that is vector product. Okay, in previous lecture we are studying scalar product. Okay, so what is meant by scalar product? See here, we are already studying the scalar product. Okay, so what is meant by scalar product? The scalar product of two vectors a bar dot b bar is defined as product of their magnitude and cosine angle between these two vectors. That means a b into cos theta. Okay, this is the scalar product or dot product. Okay, now today we are studying what is meant by vector product. Okay, what is meant by vector product? Okay, if a bar and b bar are two vectors. Okay, if a bar and b bar are two vectors. Okay, now the vector product between two vectors, that is a bar and b bar, is the third vector. Is the third vector whose magnitude is equal to the product of their magnitude and sine angle between these two vectors. And sine angle between these two vectors. Okay, now see, vector product is also known as cross product. It also known as cross product. Okay, now the vector product, see here, the vector product of two vectors, the vector product of two vectors is the third vector, is the third vector which is equal to the product of their magnitude and sine angle between these two vectors. Okay, sine angle between these two vectors. Now see here, the vector product can be defined as the vector product is defined as product product magnitude of, is defined as magnitude of product of two vectors, product of two vectors and small sine angle, small sine angle, small sine angle between these two vectors. These two vectors. Okay, now see, now what is the vector product? The vector product is defined as the product of, or the magnitude of, product of two vectors and the small sine angle between these two vectors. Okay, so vector product is also known as cross product. Okay, so see here, vector product can be denoted by a bar cross b bar. Vector product can be denoted by as like a bar cross b bar, and the value of a bar cross b bar is equal to the, see here, the vector product is defined as the magnitude of, or product of magnitude of two vectors as for the difference we are taking cross product, same a bar dot b bar. Dot product can be defined as product of their magnitude and cosine angle between these two vectors. Here are same, but here is the sin theta and here is the cos theta. So this is the dot product and this is the cross product. Okay, so the cross product is equal to a bar cross b bar is equal to ab sin theta and a bar dot b bar is equal to ab cos theta. Okay, now next point, the characteristics of vector product. Okay, now first property of vector product, that means the vector product of two vectors, vector product of two vectors, vector product of two vectors, vector product of two vectors does not always commutative law, does not always commutative law of vector multiplication. Vector multiplication. Okay, see here the first property or the first characteristics of vector product. The vector product of two vectors does not always commutative law of vector multiplication. Okay, that means we can write, that is p bar cross q bar is not equal to q bar cross p bar. Okay, that means it does not obeys commutative law, but the magnitude of this is equal to magnitude of this. So that means mod of p bar cross q bar is equal to the mod of q bar cross p bar is equal to the mod of q bar cross p bar, but here directions are opposite. But here directions are opposite. But directions are opposite. But directions are opposite. That means therefore p bar cross q bar is equal to minus of q bar cross p bar. Okay, that means the vector product does not obey commutative law. Okay, are you getting? P bar cross q bar is not equal to q bar cross p bar. That means it does not obey commutative law of vector multiplication. Okay, the magnitude of p bar cross q bar is equal to magnitude of q bar cross p bar. So here magnitudes are same, but the directions are opposite. Okay, now second one, here commutative law does not obey. Now second, it obeys the vector product the vector product obeys distributive, it obeys distributive law of vector multiplication. Vector multiplication. Now see here, that is, we can write A bar cross B bar plus C bar is equal to A bar cross B bar plus A bar cross C bar. A bar cross B bar is equal to A bar cross C bar. This is the distributive law of vector multiplication. Okay. Now third property. If two non-zero vectors, are parallel to each other, then their cross product is. Now see, if A bar and the vector product of the vector product of two non-zero vectors, in the vector products of two non-zero vectors, but they are parallel to each other, then their cross product is. Now see here, the condition is that if the vector product of two vectors, non-zero vectors, but they are parallel to each other. Suppose here is the A bar and here is the B bar. Now these two vectors are parallel to each other. That means the angle theta is equal to 0 degree. Now we want to find the vector product. That means vector product can be written as A bar cross B bar is equal to AB into sin theta. If the two vectors are parallel to each other, see here, if the two non-zero vectors are parallel to each other, then the angle between these two vectors is 0 degree. Now substitute the value of theta, so we get AB into sin 0 degree. Okay. Now the value of sin 0 is 0. Sin 0 is 0. That means AB into 0 is equal to 0. That means the vector product of two non-zero vectors, but they are parallel to each other, then their cross product is equal to 0. Okay. Now second one, if similarly, if suppose this is the subgroup part, if these two vectors are anti-parallel, that means suppose here is the A bar and sin theta according to the definition of cross product. Now substitute the value of theta, that is a b into sin 180 degree. So sin 180 degree is equal to 0. Therefore a bar cross b bar is equal to 0. A bar cross b bar is equal to 0. Okay. Now second one, third one. If the two vectors are perpendicular to each other, okay, that means suppose this is the a bar, this one is b bar, angle between these two vectors is 90 degree. So theta, here theta is equal to 90 degree. Therefore according to the definition, a bar cross b bar is equal to ab sin theta. Here theta is equal to 90 degree. So we get ab into sin 90. Okay. So here we know that the value of sin 90 is 1. So a bar cross b bar is equal to ab is equal to 8. Okay. Now see here, I will revise all this. First characteristic or first property of vector product is the vector product of two vectors does not obey, vector product of two vectors does not obey commutative law of vector multiplication. That is, p bar cross q bar is not equal to q bar cross p bar. Okay. But the magnitude of p bar cross q bar is equal to magnitude of q bar cross p bar. Order is different, but the directions are opposite. So we can write p bar cross q bar is equal to minus of q bar cross p bar. Okay. Now second property, the vector product obeys distributive law. Vector product obeys distributive law of vector multiplication. The vector product obeys distributive law of vector multiplication. That means here see a bar, b bar and c bar are the three vectors. Okay. Now see here a bar cross b bar plus c bar is equal to a bar cross b bar plus a bar cross c bar. This is the distributive law of vector multiplication. Okay. Now we want to find here the vector product or cross product of two vectors. Suppose first condition is the two non-zero vectors are parallel to each other. The two non-zero vectors are parallel to each other. Let me see here. Here is the a bar, here is the b bar. These two vectors are parallel to each other. Okay. That means the angle between these two vectors is 0 degree. So according to the definition of vector product, so a bar cross b bar is equal to ab sin theta. Okay. So substituting the value of theta in here, we get ab into sin 0 degree. We know that the value of sin 0 is 0. So the vector product of two parallel vectors, vector product of two parallel vectors condition, if the two vectors are anti-parallel to each other. Here is the OA, that means A bar, and OB is the B bar. The angle between these two vectors is 180 degree. Okay. Now, according to the definition of vector product, A bar cross B bar is equal to AB sin theta. Substituting the value of theta in here, we get AB into sin 180 degree. So, the value of sin 180 is 0 degree. Therefore, the vector product of two anti-parallel vectors is equal to 0. Now, third condition, if two vectors are mutually perpendicular to each other, that means the angle between two vectors is 90 degree. So, A bar cross B bar is equal to AB sin theta. Substituting the value of theta in here, so we get AB into sin 90 degree. The value of sin 90 is 1. So, we get the vector product of two mutually perpendicular vectors is equal to the product of their magnitude. Okay. Now, next property, fourth one, if P bar is equal to Q bar, then if P bar is equal to Q bar, then P bar cross Q bar is equal to 0. Then P bar cross Q bar, or mod of P bar cross Q bar, or mod of P bar cross P bar is equal to 0. See here, if we take the cross product of a vector with its sign, then the magnitude of P bar cross P bar is equal to 0. Okay. Now we know that, next one property, we know that I cap, see here, I cap, J cap and K cap are unit vectors along x, y, z axis, and z axis. Now we are taking the cross product of this unit vector, that is I cap cross I cap is equal to j cap cross j cap is equal to k cap cross k cap is equal to 0. Right? See here, the cross product of a vector with respect to its set is equal to 0. Similarly, the unit we taking the cross product of unit vector with respect to its set, then the cross product is equal to 0. Then cross product is equal to 0 because the angle between these two, that is theta, is equal to 0 degree. Therefore, sin theta is equal to 0, or sin 0 is equal to 0. Now, the vector product, that is I cap cross j cap is equal to k cap. Okay. Now, j cap cross k cap is equal to I cap and k cap cross I cap is equal to j cap. Okay. I cross j is equal to k cap, j cross k is equal to I cap, and k cross I is equal to j cap. Here, these two unit vectors are mutually perpendicular, that is theta is equal to 90 degree. Therefore, the sin 90 degree is equal to 1. Okay. Now, third one, j cap cross I cap is equal to minus k cap, k cross j cap is equal to minus I cap, and I cap cross k cap is equal to minus j. Okay. Now we are taking the cross products of their unit vectors. Okay. Okay. Now next property, that will sixth one. If p bar is equal to I cap px plus j cap p1 plus k cap pz, and q bar is equal to I cap qx plus j cap qy plus k cap qz, then p bar cross q bar is equal to, now we want to find the vector products of these two vectors. Okay, now substituting the values of p bar and q bar, that is p bar is equal to I cap px plus j cap py plus k cap pz cross, now substituting the value of q bar, that is I cap qx plus j cap qy plus k cap qc. Okay, now multiplying this each term to this bracket. Okay, now we see here I cap px cross this all bracket, that is I cap qx plus j cap qy plus k cap qc plus, now second term j cap p1, that is j cap py cross I cap qx plus j cap qy plus k cap qc plus, now third one k cap pz cross I cap qx plus j cap qy plus k cap qz. Okay, now multiply this into each term, so we get I cap cross I cap cross I cap into px qx. Okay, here we are multiplying to this term. Okay, plus, now I cap cross j cap, I cap cross j cap into px qy. Similarly, I cap cross k cap, I cap cross k cap into px qz plus, similarly j cap cross I cap into py qx plus j cap cross j cap into py qy plus j cap cross k cap into py qz. Okay, plus similarly k cap cross I cap into pz Okay. Now see here, I cap cross I cap, j cap cross j cap, and k cap cross k cap. Okay. Now we use this property, I cap cross I cap, j cap cross j cap, and k cap cross k cap is equal to 0. That means these three terms are equal to 0. Okay. Now see here, I cap cross j cap, I cap cross j cap is equal to k cap. Okay. So we can write first term is 0. See here, I cap cross j cap, that means k cap plus k cap into px qy plus I cap cross k cap, I cap cross k cap is equal to minus j cap. That means we can write minus j cap into px q c plus similar here j cap cross I cap, j cap cross j cap cross I cap is equal to minus k cap. That means minus k cap into py qx plus see here j cap cross j cap, that means 0 plus j cap cross k cap, j cap cross k cap is equal to I cap. That means I cap into py qj plus see here k cap cross I cap, k cap cross I cap is equal to j cap. Okay, so we get j cap into pz into pz qx plus k cap cross j cap, k cap cross j cap is equal to minus I cap into pz qy plus k cap cross k cap, that means k cap cross k cap is equal to 0. Okay. Now see here, here is I cap, here also I cap. Okay. From these we can take I cap common. Okay. So we get I cap from these two terms. From these two terms, I can take common I cap to outside. So remaining py qj minus pz qy plus. Now see here, here is the j cap, here also j cap. So I can take j cap common. So we get pj qx minus px qz. Okay. Now remaining k cap. So plus k cap. Okay. We can take k cap common outside. So we get px q bar also can be calculated by using determinant, that is here I cap, j cap and k cap. Okay, so here px, qx, px, py, pz and qx, qy and qc. So we can find by using this. Okay, or p bar can q bar, the value of p bar and q bar also can be calculated by using or by solving this determinant. Okay, now the last property, that is area of parallelogram. Area of parallelogram. Okay, the area of parallelogram can be calculated by the magnitude of p bar cross q bar, can be calculated by magnitude of p bar cross q bar. Okay, this, see here, if the cross product or vector product with respect to itself, it is equal to 0. The vector product of unit vectors I cap cross I cap, j cap cross j cap and k cap cross k cap is equal to 0. I cross j cross k cap is equal to I cap. Okay, similarly opposite. Now see here, if p bar is equal to this, q bar is equal to this. Okay, we want to find the p bar cross q bar. I substitute the value of p bar cross p bar and q bar. So this term is multiplying this whole term. Oh, okay. Now here I bar cross I bar into px qx, I bar cross j cap. Similarly we can solve, and we are using this property in here. So we get p bar cross q bar. Okay, the p bar cross q bar also be calculated by solving that determinant. Okay, and last one property is area of parallelogram. Area of parallelogram is equal to magnitude of p bar cross q bar. So first you solve p bar cross q bar, that means solve the determinant and take the magnitude of that p bar cross q bar. So we get the area of parallelogram. Okay, these are the characteristics of vector product. Okay, thank you.